please let me know that you have access to the do file and you can open it in your computer. Then I will guide you, say paths and all. पानी है क्या? पीना है तो चाय पी के आए. Were you able to open it? Do you have access to both? Yes. Please, everybody confirm, because I just do not want anyone to lag behind. Just 2 minutes, sir. So if you do not have, you have not opened so far, please let me know that you have not. We are open. Opened? Okay. Once, yeah. Eat fast, please, because I just do not want to delay. कौन सा पहले का मिलेगा? WhatsApp आइएगा. Can you see both? Yeah. Okay. First, look at this 13, line 13. Here I am defining the path where all my data, whatever I generate, they will be saved. So you must have saved your data at a particular location, right? So please give the path of that location here. So please replace, this is my computer's path. Please replace that path with where your data is stored. So you select your path. Do you know how to select your path? In the address bar? So please copy and paste your path in place of my path. Have you all done that? Now, if you have done that already, then please just select from line 9, select up to 13, the way I have done, and you need to execute. For that, in Windows, the shortcut is Control and D. If you press Control and D together, only that small part will run. And then you should have, you have created it, and then has it run in your computer? And then what you have done, if you just want to learn about it, I have defined the path, right? Global path. Remember, we were having the discussion of local and global. If I define a global, I can always recall it using a $sign. So if I write $path, that means it will just replace this $path by this entire thing, whatever I have defined. So if you use if you just run use clear, with this data set, press Control D again, then it should open the data set for you. Have you opened the data set? Data set is open for you? Yes. Who has not been able to open the data set? Please raise your hand so that I know. Why not? Okay. So once you have done the data set, then you should be able to view the data on your right hand side. What you can do when you have any data, what you can do, you can just write you can give the command to describe the data. Yeah, it's called des. And then if you press comma D, that means you describe the data in detail. Yeah. If you run that, Control D, it will show you all the data that you have. So this is a really small data set that I have given to you from our slum data set. Yeah, the slum survey that we did and the results that I presented to you. So it comes from this particular citation. Yeah, so this is a really small part of the sample that I have given you so that you can analyze, and I have, of course, harmonized the data and everything. Yeah. Sounds good? Okay. So the first thing first, did you understand the idea of sampling weight? Everybody? Yes? No? Yes. Yes. Who has not understand the idea of sampling weight? Please raise your hand. Okay. Suppose you have this big region. This is your country. Okay. Suppose this is region A. This is region B. Your population here is 10 million. Your population here is 90 million. Okay. Suppose you collected 100 samples from here and you collected 200 samples from here. So here, these 100 people represent these 10 million people. Here, these 200 people, they are representing 90 million people. Uttar Pradesh and Goa, for example. Got it? So when you do some estimate, you can, if you inflate these values to 10 million, you have to multiply by a factor. But here, 200 people, so if you multiply, do you have to multiply with the same number here or a different number? A different number, right? So all these 100 people represents 10 million, but then the 200 people represents 9 times more population. So you have collected twice as many samples, which are representing 9 times as many as population. So you have to inflate them around 4.5 times. Yeah. So when you compute an estimate, so your estimate from here is XA and here is XB, you simply cannot say XA plus XB over 300. You have to weight each of them, you have to inflate them accordingly so that they are representative. If you don't do that, then your data is not representative. Is it clear now? Does anyone still have any problem? Okay. So now in your data, you will have household weights. That means these many households are there in the region and they generally give you household weights. Now you have to make sure if your estimates are at the population level, you take into account the household size, the members living in the household size as well. So typically, the sampling weight, they are household weights, but you have to multiply with the household size so that they are representative at the population level. Okay? So here, your unit of analysis, how to check, you have something called an HHID in your data. Do you? Yes. To identify, of course, it will be varied at the slum level because different slums. So suppose I write code book, HHID, say if city, code book HHID, if city equal to 1. You see, it is saying unique value of 203. You have 203. That means at the city level, they are identifying the households uniquely. This is what Pratap was talking about, right? Unique identification. So you can see at the city level, households are identified uniquely. So this is a household level data set. So from this household level data set, if you want to have population level estimate, you have to multiply the household weight by the household size. Because different households may have different sizes, right? So this is what I do in line 21. So we had this original weight variable, which I rename as household weight. And then I say generate this could be generate actually. You can write, oh, this has to be replaced. Okay, whatever. Well, I'm replacing this original weight variable by weight age time household size. So my new weight variable is going to be the household weight times the household size. Okay, so that our estimates will be represented at the population level. So let's select these two lines and press Ctrl D. So the new household variable is created. Now, I am not showing you how to construct indicators because that itself will take 2 hours of time. It's not good value. I'm assuming you know how to construct. Pratap has already taught you. I'm assuming you know how to construct variables. Right? Whether somebody is deprived or not, I know you can write the logical sequences. Yeah, I'm not going that far. So I have got 4 variables, for example, just for illustrative purposes, right? I have deprivation in education, deprivation in health, deprivation in water, and deprivation in assets. I'm just working with 4 indicators. Is that okay? So what you can do, first you need to check if there are missing values or not. And that you can do with this command mdesc. MDESC. So if you have to, if you want to install, if it is not in your computer, you can run line 26 and it should say, if it is available, if it needs to be installed, it will install. Okay. Then if you run the next line, Control D, then it is telling me there is no missing observations. You all have the do file, right? Okay, good. So did it run in your computer? You could see that there are no missing values. So that means I'm happy to proceed. If there are missing values, of course, you have to deal with it because you cannot use missing values, right? You have to drop these observations. Okay. So the first thing first, what you should do in multidimensional poverty analysis, you should look at the deprivation. How do the variables work? Yep. I will just make an assumption to work here. I will run across all the cities to produce an overall estimate. But of course, in the paper, I don't do that because each city has its own sampling frame and all these things. I generally don't calculate, but this is just an exercise for you. So I will just do an overall estimate. Yeah, but in general, I don't do because each city and slums, they have their own sampling frame. Generally, for example, Kolkata had boroughs, 15 boroughs. Within boroughs, there were wards. The concept of wards in Mumbai is completely different from the concept of wards in Kolkata. Delhi had districts, 11 districts, okay? And then within Delhi, different districts had different pockets of slum. So sampling frames were different. I'm just computing this overall estimate just for the exercise purposes, but in the paper, I would never compute an overall estimate for all 3 cities. But I'm just doing it because it is just an example for you, yeah? Okay, so the first thing first, you look at the uncensored headcount ratios. How are these different dimensions performing? So what I've done, I have said for each variable, do you know how to run loops? How to run loops have you ever heard about running loops in STATA? Any of you? If you have heard, please raise your hand so that I know how many of you. Some of you know. So idea of loops is that if you have to do the repeated exercise, you just do not write those code by yourself. You let STATA handle those things. So here I'm using the for each loop, which I'm saying that for each variable, I'm writing as bad in this DP education, DP health, DP water, and DP asset. These are the deprivation indicators, which are 0, 1. Let's try to have a look at how they look like. So if I just type browse PR DP, no, there are actually many of them. No, let's not do that. All of the indicators will come. Let's just copy these 4. Copy and paste. So you see, I already have the 0, 1 indicator. So I have not showed you how to compute this 0, 1. I'm assuming you know how to compute this 0, 1 in STATA code. Because if I start doing 0, 1, as I told you, to create that 0, 1, I had to write 10,000 lines when I was creating MPI. Okay? If I go through 10,000 lines now, you will all fall asleep. Okay? So we are starting with the G0 matrix in that sense. Our starting point is G0 and not X. Yeah. The first thing we want to know is what is the average of these uncensored headcount ratios for these different indicators. So instead of running, okay, these run these and that, we are creating this variable uncensored headcount ratio for this variable. Look, we are using weight here. Because you need to use sampling weights. Because if I do not do that, then my findings are not representative. Yeah. So I'm computing. You may not know what R means, so just let me show you with a simple command. So suppose I write sum of a variable, sum of DP education. I'm not computing yet. I'm just showing you something. Yeah. If I type that, I get this sum value, right? But STATA stores these results somewhere. So if you type return list, these are the values STATA stores in the background that you do not see. So you can always recall these values whenever you need, you can recall these values. Look, STATA has shown this mean is stored within our mean. Sounds good? This mean value is stored there. The standard deviation is stored there. Yeah, minimum, maximum, sum, everything is just stored there. So what I will do, I will say for each variable in this, you run some of these, but then uncensored headcount ratio of a variable is just simply the R mean times 100. R mean has already been stored here. So then next, I'll be labeling the variable. Look, this is how you recall a local variable. Okay, quotation, single quotation, var, there you go. This is how you recall the variable. So it will run this loop 4 times and create this variable. So I don't have to write the code for, I don't have to repeat the code. Imagine you have 20 variables. Would you write the code for 20 times? No, you just say repeat, it's a loop. Okay? So if you select, but the thing is that you have to run this entire thing together. You cannot run one by one. So you have to select everything, all the thing together. Yeah. And then press Ctrl D. Then it should create all these values. So for education, the raw deprivation is 33.4%. This is 27%, 18.9%, and 43%, and so on. Does it make sense? Now, if you want to see how they look like in your data, because I've created those variables, so you have uncensored, right? So you just say browse uncen underscore star. So that means browse all the variables that start with uncent underscore. If you, sorry, it's called. Yeah. It's my eyesight is not very good when I'm looking at close. So there you go. So I have stored that variable for you actually. I'm not just looking at them, I have stored them inside the data. Yeah. So that is the first thing you did. Then what you have to do, you have to get to the weighted deprivation matrix. Remember, you have to define the weights from your matrix, from your deprivation matrix. You have to get the weighted deprivation matrix. So for weighted deprivation matrix, that means you have to define the weights. So suppose we have decided to give education and health 1/3 each. And we have decided to give water and acid 1/6 each. That's for the exercise. I'm not going to be, try to be democratic or whatever. I'm just this exercise. I've just decided to take the liberty to choose one. Yeah. So you have defined the weights. So again, I'm doing for each variable instead of again repeating. So first two variables gets 1/3 weight. The last two variables get 1/6 weight. You select them and press Ctrl D. If I then again go and see browse W_DP1 star, there you go. I have created the weights. Yep, 1/3 weights for the first two, and then 1/6 weight for the last two. Weights are created. I have the deprivation matrix. How should I create the weighted deprivation matrix? Just multiply. Yeah. So this is my weighted deprivation matrix. So for each variable in education, health, and so on, generate G0 weighted, that is weighted deprivation matrix, equal to the variable, yeah, times the weights. Because this is what I did, took the column and multiplied by the weight, right? So if I do that, select from line 58 to 61, press Ctrl D. Look what you have created here. Can you see in your computer as well? So you have the weights over here, and then with G0, the column, you have just multiplied the weights. And so you have your weighted deprivation matrix. Did it run in your computer? Can you see the column? Yes, no? Yes. Some yes. I need yes from everybody. Who cannot see it? Please raise your hand so that we know if you need help. Okay, run for everybody. Okay. Now, what is the next step? The next step is to create a counting vector. Right? We have the weighted deprivation matrix. We have to create a count vector for everybody. The deprivation score for each person. So we are saying we are using this egen command. C vector is equal to row total for this G0 weighted. So if you do that for G0 vector, we just have to sum. We are taking the summation of these 4 columns for each row. If I do that, if I come here and run this line 67, there you go, I get the C vector. So it is summing these weighted deprivations. Make sense? Have you all got it? If anyone is having any trouble, this is the time to raise your hand before I just move too far. What is the problem? This is very important. When I say yes, you need to respond properly. Hiding here is just going to, Priyam, is it possible to just do some help? It will be really useful. I will pause for a minute so that Priyam can find out what the issue is. Anyone else having any trouble? Do you remember the deprivation score? That's what's in it. Yeah. It is written here. If you read at line 65, it is written. You just sum your whatever deprivation you have in different indicators with weights, you just sum them up. Is it working now? Anyone else having any trouble? This is the time to let us know. Okay. I'm assuming that everybody is working for everybody. Is it not working, Prabhata? मेरा तो ये है ना Okay, I'm progressing slowly. I think Prem will find the solution. Okay. So once you have computed the C vector, let's see, we are going to label the variable. And then let's tab and see the distribution, how it looks like. Yeah. Again, we have to use the weight here. This is how the distribution of C vector looks like for the entire data set. So you can have a deprivation score of 1/6, 1/3, 0.5, 2/3, and so on. Yeah. So this is the distribution. So it's a discrete distribution because we have only 4 variables and we have limited set of weights. So this is our deprivation score, and you have the proportion. 26% of the population has no deprivation. 18% has 1/6 deprivation. 22.82% have 1/3 deprivations. Yeah, these are the scores. Okay. Now, first we are going to identify who is poor and who is not. And we are just using, say, 40% as cutoff. Somehow we have agreed 40% is the cutoff. That means you will be identified as poor if you are deprived in 40% of weighted deprivations. Okay? Great. So we just select it and we just run. So this one, this identity poor K is identifying who is poor or not. So if we go and check, there you go. These are, so these people, so given that our deprivation, our poverty cutoff is 0.4, those that have deprivation score more than, equal or more than 40%, they are identified as poor. So if the deprivation score is more than equal or more than 0.4, look, they all have got 1, otherwise they get 0. Is it working, Prabhata? Yes. Okay. So we have identified the deprivation. So those who are poor versus those who are not poor. Okay. Which one? I just identify who has deprivation score more than 40% versus less than 40%. Why did you say divided by 100? Because the deprivation score lies between 0 and 1. So if I say something greater than 40, would it identify anything? Yeah. So it's 40 over 100. What is your question?
Sir, I was just writing one step on this step. So
now is it clear?
Okay. So I'm not level variable identification.
So yeah. Can't we get local K is equal to 0.4? Yeah. And then not divide by 100? It's totally up to you. Yeah. Anything that is correct from your side is fine. Okay. So next we try to compute the adjusted headcount ratio, but for that we have to censor, remember? So how do we do the censoring? We simply multiply the C vector by this identity poor vector, because the identity poor vector has already identified who is poor with 1 and non-poor 0, right? If you multiply the C vector with it, those values that fall below 0, 40%, will just drop out, will be 0. So what we will do, we will again run this entire thing, and then look what we are doing. We are generating this variable. I will show you, but then we are taking a sum, because if you just take the average of the entire thing, that is your M0, right? You remember or not? Doesn't look like. Okay. You remember this computation? You had to take sum of all of them and divide by 4. That's your M0. Remember? Yes. So what we are doing here, we are multiplying, first of all, this censored vector. We are generating it by multiplying the identity poor, which is 1, 0, by the censored vector itself. So we will have the censored deprivation score vector, and then you just take the average of it, the R mean. That's the adjusted headcount ratio. Okay. So let's run from 81 to 85. Look here, we have created, first of all, this censored vector, which is look, for 0.16 or 0.33, they're all 0. I've censored them out. Whereas if it is 0.66, we return 0.66 because it is more than 0.4, equal or more than 0.4. So this is the censored deprivation vector. You just take the average of this column, you get M0.
So can you just repeat the loop one? I will start with loop.
I have to go all the way back. Just give me 1 second.
Give
me 1 second. Give 1 second. I will tell you. It's easy. Let me finish this one first. Otherwise, I will get lost in my flow. So the sum of the column, get from here. The sum of the column is that just, sorry, the average of the column is that just headcount ratio, right? So what I have done here, this is the sum of the censored headcount ratio, and we store the mean. That is our adjusted headcount ratio. Okay. So why I'm showing this to you, I could have just given simply some toolbox and ask you to compute. The important thing is that you understand, you know how to compute them so that you can cross check if there is any error. Sounds good? Yes. Which line? Please mention the specific line.
When you have generated the weight,
do you have the line right in the file?
For each variable,
I know the line number, please.
Line number is 40.
Good. Thank you. That just helps. Yeah. What happened?
The command is not recognized. It's writing that on the organized.
Have you run the entire 4 lines together?
Space
Space issue is
space.
because after copying that from here, some computer it gives extra spaces, so error comes while.
It's a different version of STATA.
Yeah, it's STATA 18.
space का ही होगा.
Okay, I think we'll figure out. So let's try to continue because as
Same. M0, that would be same.
no, this is I computed the value of M0. I'm just reported it. I just created a variable out of it. But no, how can M0 be same for everybody? It is for the entire country. So I've just generated a variable. That's it. Okay, so adjusted headcount ratio. So for example, if you have this variable, say censored C vector, you have this variable, right? So what you can do, you can say sum, or let's use another command. Let's use mean. Then let's select the sen C vector 40. Let's select this one. And then type AW equal to weight. Yeah. If you do that, this is your M0. So you are getting the same value that I had stored inside the column. But now the beauty is that you are getting the standard error and you are getting the confidence interval. So these are the confidence interval for given my data. These are the confidence interval for M0. Okay, so just giving the simple command, you are computing your M0, you're computing your standard error, and you are computing your confidence interval. Any question?
Actually, M0 values for the all households.
No. I have just saved it as a variable. That's it. That's all. I have not created for every household. I have just saved this variable or saved this value as a variable so that I can use it later. That's all. Yeah. I just saved it as a scalar, but there is no other way of saving it. Yeah. But this is a scalar, 0.20. Okay. Great. So now, how would you compute the multidimensional head count? Similarly, if you want to save it as the scalar as a variable, you can run this code. We will run this code because if you run this code, look, it will again save it here. So it's 32%. Yeah, this is the adjusted headcount ratio. Now, if you just want to compute the confidence interval and everything, again, mean, and then you select the variable identity for 40, AW equal to weight. There you go. This is your multidimensional headcount ratio, 0.32. You have your standard errors, and then you have your confidence intervals. Okay. Now it's time to compute A, intensity of poverty. But note the intensity of poverty from here is just the average deprivation share among the poor. So it's the average only if you are poor. So what you can do, again, sum of the censored C vector that we have created only if this identity poor is equal to 1. So you take the sum, but only if they're equal to 1, that means only among the poor. So again, you save it. So if you run it, you save it, again, your variable is created. So your M0 is reported here, H is reported, A is reported. You just multiply them, you can cross check. One should give the other. The product of the two should give the other. Okay, so your M0 is 0.20, your H is 32 point something percent, and your A is 61.34%. Done? Any more questions here? No, so I'm progressing. Okay, now it comes the censored Now it comes the censored headcount ratio. Can anyone remind me what censored headcount ratio? Yeah, let's work hard together. Why should I work hard only? You have to work hard too. Yes. Proportion of the poor. Proportion of the poor, but that is multidimensional headcount ratio. What is censored headcount ratio? The proportion of people that are poor, multidimensionally poor, as well as deprived in that indicator. Yes. How do you compute it then? You have the deprivation in particular indicator. You know who is poor and who is not. How then do you compute the column to compute censored headcount ratio? Yeah, how? So you have a deprivation vector. You know this person, this household is deprived, this household is not, and so on. You know the uncensored deprivation column, right? You know a column from where you know who is poor and who is multidimensionally poor and who is not. How do you compute the column for censored deprivation? Vector is some of dimension. Then we can filter that value should be more than but we have already computed the is identified as a poor and in which variable that person is poor. Yes. How we create the censored deprivation. Yes, but here how do you do that? So for each variable, so for each of these variables, you know they are 0, 1, right? So for each of these variable, we are creating a new vector, which is that variable reflecting uncensored deprivation. And we are simply multiplying by the 1, 0 variable that is giving me poor or not. Okay? That is simply giving me the censored headcount vector. So we are doing it and we are going to run it up to here, up to 110. If you run it, you create it, yeah? And then if you just take either the sum or mean, whatever you do, yeah, so here you have, this is your uncensored at the top 4 are uncensored and the bottom 4 are censored. Do you remember the difference between uncensored and censored? What is that? So which one should be larger, censored or uncensored? Uncensored. Who thinks censored should be higher? Please raise your hand. You don't have to be scared. It's okay. You will not be targeted. Don't worry. Who thinks censored will be higher? Who thinks uncensored will be higher? Okay. Now the trick question: why? Because it's a raw headcount. Okay. So you are leaving out some of the deprivations for the people who are not poor. That's why censored has to, if ever in your computation you find that censored, you found a value of censored higher than raw or uncensored, you are dead wrong. You have done something horribly wrong. It is not possible. Censored cannot be higher than the uncensored. Technically. Okay? I have seen such a thing in one paper. Somebody gave me a dissertation chapter to examine and had such a mistake. Well, that's not possible, right? So he or she must have done something horribly wrong in the computation. This is method. Louder, please.
What is this SAT 15 in the last one?
It is separator. So, sometimes if I compute these values for, say, a large number of, here we have only 8, right? Variables. If I have 20 variables, I need a separator to understand, to read them. It is easier for me to read the separator of 15. So if you have 15 rows, then you will be separated and then you will continue and so on. So you can run it with 4 separator. Let's see what.
3, 4.
So if you have, say, separator equal to 4, let's see if it works. Yeah, you have a separator of 4. So after 4, you have a separator. Yeah. And now what you can do here, if you want to have the confidence interval as well, what you can do, instead of this one, you just copy it, paste it here, and then write mean. If you simply write mean, then you get the confidence interval as well. Sum does not give you confidence interval, but mean does. If you do mean, look, it is giving you the standard error as well as the confidence interval for the entire data. Okay? Are we all on the same boat? Anyone lagging behind? No? Okay. Now let's try and see how to compute dimensional breakdown. Yeah, absolute and percentage contribution. Okay. Now, if you remember, going back, this is what we had, right? So we literally had our M0 is equal to weight on indicator 1 times sensor headcount ratio plus weight on indicator 2 sensor headcount ratio, so on. So the absolute contribution of a particular indicator, so indicator 1, is going to be the weight on indicator 1 times the sensor headcount ratio of indicator 1. This is the absolute contribution. And for percentage contribution, what you have to do, did I have the formula? It's intuitive, I didn't write it down. No, I didn't write it down. So to compute this one, which is the relative contribution, you will take the weight, say W1, weight 1, times sensor deprivation 1, divide by the adjusted headcount ratio. That will give you the contribution of one indicator. M0, adjusted headcount ratio. So if you come here, you just take one of them, divide by the adjusted headcount ratio, that will give you the contribution, isn't it? So if you simply have your M is equal to, suppose for 2 indicators, W1 CH1 plus W2 CH2. If you have that, this is your absolute contribution to M0, and your relative contribution is going to be W1 CH1 divided by M plus W2 CH2 divided by M. The total contribution will be 1 or 100%. Clear? So this is what we now need to compute for this one. So what we are doing here, this is dimensional breakdown. So the absolute contribution is basically the sensor headcount ratio times the weight, and the percentage contribution is equal to sensor headcount ratio times the weight divided by M0. Exactly what I had written in the board. Yeah. So you can run up to 121, line 121, and run it. And this is what you get. Yeah. Now, what you can do, type sum of absolute contribution. So this is what you get, your absolute contributions. So ideally, if you just add them up, you should get them 0. Yeah. Similarly, if you just run the percentage contributions, there you go. You have the percentage contributions, add them up, you should get 100%. Yep. 40 plus 30, 70, and then 30, yeah, around 100. Yeah, you should get 100. Make sense? Look, if your computation is right, they all have to match up. There is no way of escape, and this is exactly what I tell you about when you use PCA or statistical methods. Whatever you do, you need to show me that things are matching up, accounting exercise at the end of the day. Now you come to me and suddenly tell me that I have used this method and I have got contribution to be higher or lower. Why? How did you get it? Things have to match. If I cross check from different angle, the numbers have to match. Right? So that's what I have issues with some of the statistical approaches. I just do not see how they match up. Good. Let's move on to subgroup decomposition. And now this one is the real one because now I will be subgroup doing the decomposition by city, which actually should be. Because these overall figures do not make any sense because all cities have different sampling structure, but just for exercise, I showed you how to do it. Yeah. Now what we are doing is the real one across cities. This is what this data is represented for. So when you do that city by, so here I'll be doing by city, but then if you want to go by city and household head, you have to define new variables and so on, or you have to write by city and head of the household, or by city and caste. So you have all the variables in the dataset. You can play with it at your own time. Okay, I don't have all the, so this is also the dataset that my master students use to write a project report every year. Okay. I do not give them any computation. I'm showing you how to do so, but I generally, they have to compute by their own. I just go through them, just like I'm going through you, but they have to use those data sets to compute whatever they want to do. Yeah, so I just show them basic things on how it is done. But so they have the caste, religion, everything, but they have to compute. So they literally have to write a 2,000 words report, as if they are comparing two cities. They are the advisor of the municipal corporation or whatever. Okay, you can try to do yourself, but please don't send me. I don't have time to read through your report at this moment. Yeah, I already read many of their reports earlier this month. Anyway, so if you could just do tab stat just to understand, how these different cities are doing. This is kind of what you get. These deprivation. So these uncensored headcount ratios across different cities. This is the picture you get probably. Yeah, you could do it separately. If you can give me if command and all. However you do, this is what you're going to get. Yeah, you can write mean 4 variables, weight, if city equal to 1, if city equal to 2, you can get them as well. But in the abstract, you just get it in one go, the overall as well as across different cities. How am I doing with time?
So here we are getting column as 100. You can also get rows as 100. Because every system wise.
Yeah, sorry, what did you say? Yeah, 1 hour. Okay. Yeah, you can do. You can literally do whatever you want. Then, suppose we compute the multidimensional headcount ratio by region. Again, we already have variable. We have already defined it. Yeah, but it has a local escape. If you run it again, you get now the multidimensional headcount ratio by region. Right? You had a question about where to use weight. Do you see where I'm using the weight?
Yes, sir.
So for all this sum and everything, you have to use the weight. This is how you get it. Make sense?
Yes, sir.
Good. Okay. Similarly, for intensity, of course, you have to add this additional term if identity 4 equal to K. If you run that by city, you get the A. These are intensity of poverty. And then finally, you just use the enter censored C vector and run it. There you go. These are your adjusted headcount ratios. To get all of them, you can cross check. If you multiply with the H and the A, you will get the columns. I always do the cross checks. You can also do it at your leisure time just to make sure your accounting exercise matches. The ledger book has, matches, whatever your liabilities and assets, they are all accounted for. Anyway. Similarly, you can do censored headcount ratios. Here, what we are doing, again, here I'm doing double loop. The first loop, I'm saying for each variable, because we have to do the censored headcount ratio for each indicator, then for each region. So I'm saying for each variable, and where you have, for understanding, I would have also, sometimes variable. For each variable, you have education, health, water, and asset. Then I'm saying for values are equal to 1, 2, 3. 1, 2, 3. 1/3 means 1, 2, 3. Okay. Sorry? This one. 146. No, R is just a value. Just like variable, R is a value which takes a value of 1, 2, 3. Oh. Yeah? And I am using CT is equal to R. So CT can take 1, 2, 3, right? If CT is equal to 1, create this. If CT equal to 2, create this, and so on. So I've double loop here. We have 4 variables and 3 regions. Yeah? So if you do that, if you run 144 to 152, there you go. You have for all the indicators, region 1, things for region 2, region 3, region 1, 2, 3, 1, 2, 3, and so on. Yeah, so this is how. So again, it's a repetitive process. You can try to do your way, the way you want. This is one way of doing, but I'm not claiming my coding is the only way of coding. I'm a very silly programmer. I do everything step by step so that I can see even if I come back after 7 years. Because I don't want to sit in front of a computer and try to imagine what I wrote or try to remember what I wrote 7 years ago. So some publications take 4 to 5 years. Yeah, and I do not want to come after 5 years. There's so many projects running at the same time. So it is always good to keep good notes in your do file so that even if you come back, whenever you come back, I think I wrote these 15 years ago and I'm still teaching it to you. Of course, I had to improve it in the middle, but if I did not keep proper note, I'll just forget everything. I literally tend to forget whatever I do after 3 months. If you ask me what I did in February, whatever I wrote, I don't remember anything. Forgot it. I'm a researcher. Teachers may remember, but I just don't remember. Okay, so it is very important that when you run your code, you write it in a way that you yourself can understand it after 3 years. It's very important. Okay? Good. Similarly, you can compute the absolute contribution by region and so on, and I'm not running it again. It's just same. I'm sure the code will run. And you can compute the absolute contribution and the relative contribution by city. It's the same thing. It's the same idea that I just recycled. It's the same way you can compute by city, you can compute by caste, you can compute by religion, by head of the household, whatever data you have, whatever variables you have in the data, you can use them to compute. The same process. Sounds good? And I hope that you should be able to adapt it to your own research. Should not be a problem. Any more questions so far?
What is total yield?
Huh?
Total liquidity was district headcount ratio or when we compute the district headcount ratio for city, it is a total at the end.
Yeah, the total should match with the total, huh? The overall, say all three cities, if you put
The entire number.
this is how it should be. And if you are not happy with that, this is always good to cross check. Run, compute the value and see if it's matching or not. And that's what I do. So that's why you need to do different cross checks to make sure whatever you're computing is robust, your calculation is correct, because we can always make errors in our coding, or we may not, STATA is not computing whatever we are expecting it to compute. It can happen. It's always good to cross check. So we already computed earlier 0.20 or whatever, that was the overall, right? Mathematics, yeah. Yeah. R equal to 1 to 3. So that means R equal to 1 to 3. So because city is equal to 1, right? So if you see, that's what I have recalled. So I'll use that command for values R, and then I have recalled look R here. So if R takes 1, you are computing for city equal to 1. If R equal to 2, city equal to 2, you are doing it for, yeah. So it is, I think, Kolkata, Delhi, and Mumbai. So this is how it's computing.
Sir, what the standard last one? In the table.
Because I have computed it for, I have saved just this value here, so they all have the same value, right? So I'm just recalling it. That's all. Yeah. If I have to produce a confidence interval, I use the mean command. I generate the variable and use the mean command to generate. I have saved all these values for you so that they are stored here. Okay. Now, again, if you want, you can save this data. Say I run everything. I say, suppose even if I run this one, you can save that data if you want. I'm not going to save it. It's already saved. Now, if you give this collapse command, yeah, see what this collapse will do. So I'm saying collapse these variables by city. If I hit it, say run line 180, look what it did. It just collapsed all these variables by city. Yeah, so these are values for each city. I think I forgot to mention the name of the city itself. Collapse, yeah, I just had to write city itself, by city. If we do that, then it is literally reporting the values for these three cities. So whatever we computed, it has just collapsed. So the M0 values and so on. Yeah, anyway. Okay, now what I will do, I will talk a little bit about the sensitivity analysis. Okay, what is sensitivity analysis? Is you look at the dominance, how to compute them. I suggest that you generate the thing in Excel. So you can generate the, I will show you some way to transfer things in Excel file. Yep. But then if you are a better coder than me, then of course code. There is also an MPI command. Does MPI generate the dominance graphs and everything? It does, right? Okay. So there is an MPI command itself. I have not been able to sit down, although I have been requested several times. I have time to go through it. But there is an MPI toolbox in STATA that allows you to generate the dominance curves and everything. But what I will show you is how it is done. Because whatever they generate and whatever is generated, they use this program, this coding, this understanding to generate. Yeah. But is it clear so far? The tools that have been generated.
Sir, is it possible to generate the Venn diagram that you showed instead of one?
I have never tried Venn diagram to generate, but it should be possible. We have just, so in general, how I have learned STATA, I just go to STATA or whatever or outside, just type STATA Venn diagram. There must be some command. If you just,
Four-dimensional is not possible instead.
Huh?
Four-dimensional is not possible.
oh, you must have some, something in Python or whatever, maybe, 4-dimensional. I drew that by my hand, using my hand. I did not draw it from software. I have never used Venn diagram in that sense that I have to compute, because Venn diagram I have used just for illustrative purposes. So I just draw it and I mention the number in the middle. This simple tool, right? Why do I have to generate Venn diagram? So I have never generated Venn diagram. Why do you generate Venn diagram from STATA?
The data which we have specified.
The basic to see the overlay.
Yeah, but you should draw the overlap and write the number. It's done. Why do you have to generate such a sophisticated graph just to match the size or whatever? It works with hand. Why? Honestly, why do you need it? It's a simple tool. Why work so hard to generate Venn diagram just an illustrative purposes? I don't know. Honestly, I've never done. But there must be a way. I think. But four dimensions, I don't think so. But 2 dimensions, maybe you can just search for STATA Venn diagram. Any of you are even online or something? Just type STATA Venn diagram and see what turns up. Huh?
So in STATA, any kind of control means you need high storage in your system first. The most thing is, if you have high storage, then only you can proceed for any visualization aspect of, especially Venn diagram or any kind of.
But it is possible to do Venn diagram.
Yeah, it is possible.
There you go.
In graphics,
There you go. People know it should not be that difficult to find out. Anyways, okay. So for robustness and sensitivity analysis, what we do to generate, so you can use, if you have saved the data, you can use the data, but if you have not collapsed or whatever, the data should be there. Yep. So if you just start with the data, because I collapsed, so I lost my data and everything, all my computations. So again, you start with the tabbing and you see this is how it looks like. Then for dominance analysis, what you need to do, you need to generate these values for every cutoff. Yeah, 10, 20, 30, 40, 50, and so on. Here we have discrete cutoff, so literally we will have 20, 40, something like that, but I generate for you anyway. So look, for values, k equal to, this is how you write 10, 20, generate starting from 10 to 100 with a gap of 10. So that means 10, 20, 30, 40, and so on. Yeah, so this is how you generate the values for. So if you generate them, this is, you are generating for multidimensional head count ratio. Yeah. And then similarly, this is where you are generating the sensor deprivation score. Again, what you are doing, you are generating the sensor deprivation score for say 10, 20, and so on by multiplying C vector by that identification, as we have done the 0, 1 identification. Yeah. So that will give us, the sensor deprivation vector. Now, if you do sum of all the ident4, for dominance, what we have generated, 2208, there you go. You have all the multidimensional head count ratios for different cutoffs. Now, some of them will be repetitive because, as you know, our data is quite descriptive in nature. We do not have enough variation. Yeah, we have just limited number of weights. But there you go. You get the values for different cutoffs. You can just simply plot it in Excel file, and you will get dominance curve. Okay. You can do it by city as well to get the dominance curve of the cities. Similarly, if you just again type the sum of There you go. These are your M0 values. These are your adjusted headcount ratios for different cutoffs. Sounds good? Okay. And then similarly for A, you can simply compute by doing if identity 4 equal to 1, and that will definitely give you your A values. Look, for very high, 90 and 100%, of course, your A is equal to 1. Because everybody that are poor, they have it is intersection approach, right? They all have a value of 1, so the average is going to be 1. Just to know, cross-check that we are in the right direction. Sounds good. Now, let me move forward and show you something addition, which is standard errors, confidence intervals, t-test, and all these things to show you a little bit. Yep. Have any of you heard about SVY set? Yeah, this is survey set. What do you do here? Your data, they are collected using STATA, right? STATA and PSUs. So what you need to do, if you just define them early, you do not have to recall that AW equal to weight, AW equal to weight all the time. And your standard error will make sure that is adjust for STATA, the STATA and PSU and all this thing, the stratification, because they are not completely. So far, when we are doing AW equal to weight, we were getting just assuming sample is completely random. But sample may not be random. Yeah. So if they are not random, you have to provide the sample stratification inside. And this is how you define. So I'm here to, I have just assumed that HHID are, they are the PSU themselves, and the cities are the STATA. I'm just assumed it for running. But in actual data, in IHDS, in NFHS, in NSS, you will have the STATA and the PSU mentioned. So what you have to do, SVY set PSU, then the weights, and comma, STATA, and the variable STATA, whatever it is. You have to write that properly. But every data set will have, survey data set will have that information for you, STATA and PSU. Okay. So if we define it, it is defined. There you go. Then we are just simply doing that for k equal to 40, just compute the mean of identity 4 and the mean of sensor C vector for 40. So here you get the multidimensional headcount ratio, but now the confidence interval should take into account the stratification of the data because your sample is stratified. So you are getting from here the standard error and the stratified confidence interval. Yeah, the standard error is also stratified. Same thing here, you also get it, the M0. Now, suppose you want to do t-test between regions, or you want to conduct t-test between caste groups, or t-test between male-headed household and female-headed household. How do you do it? You just, for k equal to 40, suppose I run this SVY. Look, I'm just writing SVY mean. I'm not controlling for weight anymore because weights are already defined into the SVY command. So I'm just using SVY, and then I'm just giving the command. If I do, this is what I get. Yeah. So I have asked it here that list this coefficient, the coefficient, because I need to know how STATA is saving the data. And look, this is how STATA has saved. So this value correspond to STATA has given this big name to save this value, the coefficient. Yeah. Now I'm going to test between, say, suppose I'm interested in testing between Kolkata versus Mumbai. So this is the value for Kolkata, _B and so on. And this one is for Mumbai. So what I'm doing, I'm saying, just test Mumbai and Kolkata. Yeah. If I give, there you go, the test statistics. Statistically significantly different or not. Okay. Because if you do not do statistical test, then you will not be able to say whether a change, an increase or decrease you cannot say anything about it. Basically, the null hypothesis is they are equal, the alternative they are unequal, right? If you cannot reject the null, you cannot say they are different. They will literally be the same. But of course, that will depend on your sample size and so on. Typical basic. Sorry?
This command only see your identity understood to the right.
This comes from here. This is how STATA has saved it.
We have to trace, we have to give this command.
You can have other command. There is a command on t-test as well. That gives you the mean, difference in mean and the test. You may have alternative commands. Yeah, but this is one way of doing it. Yeah, but you can.
If you are having suppose to measure states, you have been doing an analysis, then you have to give large number of combinations, like each state with other state.
Yeah, you have to run a loop. You have to run a loop, and then you can set the data. Yep. Okay. So how you do confidence intervals for all of them? Yeah. Look what you can do, confidence interval for say multidimensional head count ratio for all values. Yeah, so 10 values. So what you can do, you just select all of them. Look what I've done. I have computed the standard errors of age, they are all saved. So if you give return list, they're all saved below by STATA, right? So I'm computing saying, okay, standard error of age is this value, STATA saved. And lower bound of age is these values, STATA saved. But look, to compute the confidence interval, what you take the point estimate plus minus critical value times the standard error. So I just computed the confidence interval. Who had the question of confidence interval computation? There you go. This is how you compute confidence interval. Does it make sense? There you go. Okay. So it was already there. So if you run that, there you go. You have the confidence intervals for all values. So these are your multidimensional head count ratios. And then you have the confidence interval. These are all lower bound. And these are all upper bounds. So you get all the lower bounds and upper bounds. You just compute them. Now,
The command, why we're dropping that AC underscore
because if I want to run this line again, it will tell me, oh, that variable already exists.
already, like, once we are doing it, unless until we need that estimation again.
But you are needing it. You are running the loop. You are creating that ACH for when k equal to 10. You are creating again when AC equal to 20, when h equal to 20. Right? In the loop, you are doing it again and again. And there is no point in creating that variable and, reserving the memory. So you just drop it, you run it again. Make sense?
Yes.
Okay. Now I'll show you an alternative computations because you are sitting here and saying, you are computing everything and they were expecting us to copy and paste everything. Okay, not bad, work hard. I will show you an alternative way of computing. It's a bit complicated, but you can export all the results together in Excel file. I'll show you one example. Hopefully you'll be able to try and do it on your own the other times. Yeah. Okay. So what I'm doing here, this is an alternative computation. Yeah. So I'm running this thing first, SVY mean, identity code dominance star. If you run that, then of course it runs everything. It computes, it saves everything, right? So if you go here and say you write return list, you have this table R table. Now I write mat list R table. Look, all these values are stored in this matrix. STATA has stored all these values in the matrix all together. So STATA has done a beautiful job for us anyway. So in the first one, this B is the estimate of multidimensional head count ratio for all 10 cutoffs. These are all multidimensional head count ratios for different cutoffs, right? Then you have the standard error saved, right? Then you have the lower bounds are saved here. These are all lower bounds. And these are all upper bounds. And you are wondering, okay, we have these values. Instead of copying pasting, why don't I give a command and then everything is saved in Excel file? Side by side. Amazing, isn't it? You have to work hard, huh? I'll show you once. Hopefully you'll be able to figure out the rest by yourself. No idea. Never tried to. I'm happy with my estimates. No idea.
Either 10 days to
Okay. So what I'm going to do, I'm going to create a matrix. Okay. This matrix from this R table, I'm going to transpose it. So I'm going to write matrix X equal to R table prime. If I run and I say mat list X, there you go. Everything is now in column form. This is how I want it in STATA. How much time do I have?
Enough.
I'm talking quite a lot, but I have no idea. 40 minutes? Good. So, then what we are going to do, the B, for B, what we are saying that, take 1 to 10, row 1 to 10, but save column 1. Lower bounds are from X, take column 1 to 10, rows 1 to 10, but column 5. Look, column 1 has B, column 5 has lower bound, column 6 has upper bound. We just need these 3, right? Right? We need the estimate, the upper bound, and the lower bound. If you need standard error, you can have standard error. That's fine. So what we will do here, our B is equal to X 1 to 10, but column 1, lower bound is 1 to 10, column 5, upper bound. So we are creating these 3 matrices. Yeah. So if you just say mat list B, there you go. All your adjusted headcount values, they're all saved here. Yeah. Similarly for LB, UB, they're all saved. Similarly, this is for city. Yeah. For cities, you can generate the same thing, and these are for 3 cities. City is equal to 1 for Kolkata, city equal to 2 for Delhi, city equal to 3 for Mumbai. You run all of them. Sounds good? Then you are creating a matrix called H, which has the overall H, lower bound, upper bound, Kolkata H, lower bound, upper bound, Delhi H, lower bound, upper bound, and so on. So you are creating, just type mat H and say mat list H. So you have all the values, the overall headcount ratio, lower bound, upper bound, Kolkata's multidimensional headcount, lower bound, upper bound, and everything. Yeah. Then you have to create an Excel file. You can create a blank Excel file. Yeah. And the blank Excel file, you create, say, results. So here you come, I created this Excel file already. You can create, why don't you create one blank Excel file in the same folder where you have the data. Create a blank Excel file and give the name of the sheet, this one, as H. Please create a blank Excel file.
Same folder.
Yeah, on the same folder, create a blank Excel file and give the name H. The name of the sheet, sorry, the file name should be result, RESULT. Name of the file is result. And then please create a sheet called H, capital H.
Is it due to the command if it's already generated?
No, it should not.
I didn't open the Excel file, but
There is already one.
I just run that command.
I think then you ran the command and it created it. Perfect, perfect, perfect. Wonderful. Then STATA has improved. STATA 16 didn't do it. Okay, wonderful. Let's run and see. So what I'm saying is, so what I'm trying to do here, put Excel, yeah. So I'm saying there is a sheet, but then put all the entire matrix H, paste it from column A2 onward.
If we're running both the course, it is already generating in that Excel.
Done. So if you run that, do you get this Excel file? All of you? No, right? So then it differs data. So please generate your result file. Create an empty Excel file called result. Have you generated? Huh?
Follow the step it is said.
Please generate an empty Excel file. Just create and save an empty Excel file with the name result. Name the Excel file RESULT. Just create an empty Excel file in the folder. Once you have created, let me know.
This STATA is working automatically.
There you go. In some STATA, it doesn't work. So STATA is getting smarter.
I'm working on 17.
Then 17 is working. But 16, 15, 16 is working.
path change.
So you have created the result. Now, once you have created, please create a sheet called H, capital H, just like this one. Name the sheet as H. Yeah. Please save the file and close the file. Then if you go to Excel file and run line 271 and 272, what I'm doing from cell A2, I'm just pasting the matrix. This matrix that I have generated over here, I'm just pasting this matrix from cell A2 onwards. Yeah. So if you do that, run that part and see, you see the change in the Excel file. You go to the Excel file. You open the Excel file. They should be there, right? Have you got?
नहीं तो खुल रहा है नहीं खुल रहा है ये तो मैंने खोला हुआ है खुल नहीं रहा है
It should be there, right? You have saved in the same folder path. How you have defined? Haven't you saved in the same folder? So it's given already.
खुद से एक फोल्डर बना
यहाँ से
एक्सेल बना
ठीक है
Because you have probably left your file open. You have to close your file. You have to close your Excel file. Now run it, please. What name did you give? Did you give the same name, RESULT?
Yes, sir. Yes, sir. The same name. Results.
Did you create the sheet H?
yes Alex yes sir.
Are you checking is the same path? Path is okay? Did you save in the same folder from where you opened the data?
अब जनरेट कर नहीं यार नहीं हो गया
Please try. It will work for some, and I have no clue why it is not working for others. I'm not a programmer, so I cannot say. It's worked, right? Okay, it worked. So for whom it didn't work?
The column names will come automatically or we have that? Like
Column
that,
names
put
will not
Excel.
appear on the.
You can define the column names. So you can go to matrix, search in STATA. STATA must be a way of writing the column names. Yeah.
But in this case, you have to do it manually.
Here you can just write it manually, but in STATA it is possible to write the column names. Yeah. You have to define the column. But what I do in general, so I do not just save the data here. I generally tend to save the data somewhere on the right side. I create my tables already. Okay. Let me see if I have an example. So suppose we have this data. So this is the table from one of my papers. So what we do, I save all the data here on the right hand side. So all these things come from STATA to the right hand side. Now what I do here, I just format this table and link with the formula. So that every time I run the results, I save the results on this side, which is hidden, all the tables are automatically uploaded. So you don't need these column names or whatever, There may be other way, EST tab or whatever other ways to generate tables, but this is one way we can export it to Excel, manual way using put Excel. Okay, I've given you one exercise to run that thing, do that thing for M0. That's your evening exercise. Try that, good for you. Okay, let's see what else do I have. So similarly, if you run the next part, you get the adjusted headcount ratios for all the cities. There you go. So here you have the adjusted headcount ratios for all the cutoffs. You can do it by city. City equal to 3, city equal to 2. Again, you can take these results in Excel, and then you can easily draw the confidence intervals around and whatever you do. You all know Excel, right? Yes, no?
Yes.
There you go. I'm hoping you all know Excel. So you can just get the data, generate, take it to Excel. The graphs are already created. If you create the graph, you just have to send your data there. All your tables, all your graphs will be automatically updated. You have to just create them once, and every time you just modify and send the data, everything will be automatically updated. Okay, you can create such framework for yourself, but this is how we all do. And one day, if you are just good enough, you just create a STATA code. This is how they are created. This is how we researchers create things. But I just don't have the patience. I would rather spend my time writing papers rather than creating STATA codes. I can do that. I enjoy coding, I enjoy programming, but I cannot give my career to coding.
But the STATA could also get published in STATA language.
I don't care. Other people may have time. Good luck to them. Look, I cannot publish everything. Yeah, I have my limitations. I have my time limitations, and I have my interest. I can. That does not mean I have to do. Right? Sorry? Preferences. Yeah. I have to, but I have preference over others. Comparative advantage, you could say. However you want to say. Anyways. Okay. Similarly, you can, this is the last thing I just wanted to focus. I just wanted to let you know is that, for age and when you are computing multidimensional headcount ratio or adjusted headcount ratio, you have the entire sample, right? From the entire sample, you are computing the standard error or the confidence interval, right? When you are computing the intensity is computed only for those that are poor, right?
Yes. Yes.
Right?
Yes, sir.
So for intensity, A is computed only based on the poor. Now, when your poverty cutoff is higher, you get smaller and smaller sample size for computing A. So the chance of getting a really big confidence interval is high. So most likely, if you compute that way, your A is not going to be statistically significantly different. So there's an alternative approach. The alternative approach is that you compute the confidence interval of standard error for A from the ratio of M0 divided by H. So you have computing the standard error of M0 and H are not a problem. So for A, you just write it as M over H. Can you do that? We know the standard error of them, of M, we know the standard error of H, and the ratio, the standard error of the ratio is going to give us the standard error of A. In that way, your confidence interval will be good enough. It is not just going to be inflated because of smaller sample size. Okay. So this is what we do in our last step. So you will see standard error of A. Look, there is this really big formulation. It is mentioned in the book in chapter 8. The formula is given. Yeah. It is going to be a big formula, but which is drawing from this variance of H and variance of MPI. So I run these two together, show you. So if I run these first two together, if I just run these two together and then I'll show you. Oh, sorry, I have to run it together. Let's just take 40 and then 40. If you run these two means together, yeah, and then you say E return list, you have this EV as the variance covariance matrix. So mat list EV, this is your variance covariance matrix. So this is the standard error, variance for the headcount multidimensional headcount ratio. This is the variance for the adjusted headcount ratio. And this is the variance, covariance between them. Yeah. What we will do, from there, we are going to create the covariance, the covariance as covariance 2-1. So column 2-1, row 2 and column 1. 2-1 is going to give me the covariance, which is covariance over here. Variance is from this matrix is 1-1. This is the variance over here. And the variance of M0 or MPI, however you call it, just code it as MPI, it should be M0, is covariance 2-2, which is hidden behind this one. So once you have that, then the standard error of A is computed by this formula, which is again mentioned in the book. It looks ugly, but if you just write it, it's a small form. Yeah. So once you have that, so that is one way of computing the standard error of A. This is how it is computed. Yeah. So let's see. So for values, if you just run, there you go. You are getting. These are the values and the confidence interval, let be A of 10, 20, and so on. Sounds good? Similarly, if you want to take them to STATA, you can just take them the way I have taken for each headcount. If you want to run that exercise, you can try that. Sounds good? I'm going to finish it here. Hopefully, the tools that you have got, you can do many more things. Question time.
Sir, is the course related to the paper which you mentioned?
Sorry, is that?
The explanation of all
No, the data. The data basically is I have taken, so it's a large data set of around 3,000 observations. I have taken a small part of the data. So that data comes from that paper. That's why I mentioned it there. But you cannot replicate the data because you don't have the data. You can replicate the results because that results is based on a much larger data set and more variables. But just for this variable, just for this exercise, as well as the module I teach at least for master students, I just extracted a small part of the data just to illustrate what it is. But no, you cannot replicate the result. Yeah.
So we have checked the business with the identification of for different poverty cutoffs.
First,
For different poverty cutoffs,
yeah.
you are checking the business and then sensitivity. So Is it, I mean, we have to do all these things, I mean, to adjusted head count ratio and
It totally depends on you what you want, because I showed you two of them, right? If you remember from this lecture earlier. Here. So here, I did it for headcount ratio, multidimensional headcount ratio. I also did it for the adjusted headcount ratio.
so all these three measures have to be robust. I mean,
What do you mean have to be? It may be robust, it may not be robust. This is what you are
at the
testing.
same time, at the same time. For example, if we are looking, we are checking for headcount ratio only, and then intensity. So all these two measures, headcount ratio, adjusted headcount ratio, and intensity, have to follow the same sort of.
Not necessarily. I mean, if you look at multidimensional headcount ratio here, this is your multidimensional headcount ratio. You have crossing. So not necessarily. If they do, then well and good, you are fine. But it's not necessarily there. That's why you are checking, right? You are not checking because you are certain it will be okay. You are checking whether it is okay. Right? So you may not get dominance. You may have intersections. So suppose you get your value gate adjusted headcount ratio is higher for one city, but when you plot the graph, you see there is crisscrossing. So then that's a problem.
Okay. So when we have intersection, then how, what is the do next?
You cannot say, at least you can say your comparison is not robust. Yeah, so here the crisscrossing is happening in one extreme. What I could say from here, look, between 4 and 9, you have dominance. I mean, at the extreme, probably we don't, but for the majority of the part, we have dominance. You can make some conclusion, but whatever you do, you are not hiding it. That's the point. As long as you are open, that's fine. We report as academically, whatever we find, we report. A paper is not always about having significant results, because sometimes many people do that, oh, I didn't find significant results, so I decided to drop the paper. It is not about always significant, it's about doing the right thing. If you don't get the result, report I didn't get it. There's no harm in that. That's why you are checking. It is not necessary that you will always get the results that you think you should get. It is not possible. That's why you are doing the robustness test. It may be possible that you do not get what you wanted. Okay?
And the second question is regarding the
You're getting weights. Yeah.
when we compute the MPS,
Mhm.
the headcount ratio, then we use different weights.
Yeah.
Then for standardized errors, we use sampling weights.
No. Sampling weights and dimension weights and sampling weights do not get.
I'm not talking about the dimension weights. I'm talking about the AW and PW.
Oh, they will give you the same result. I have not seen any differences, whether AW, IW, PW. I have not. I know they are different, but honestly, I do not know whether that makes a big difference in my result. I always get the same results. Whether I use IW, AW, PW, most of the time. Frequency weights, if you have decimals for what it's not going to work. But otherwise, I get. Have you ever seen different results?
Ideally, I think it's there are no major differences. However, we should use periods because
Probability weights and all this. But we do not, in our work, we do not see much differences for them. They almost give the same result.
The third question is regarding how do we assign weights? Can you
Now, which weight? Tell me. Dimension weights and sampling weights. How you assign sampling weights? When you create sampling weights. Okay. So the same picture that I drawn here. So you have to know the population. Unless you know the population, you cannot do the sampling weights. So suppose you go to a village. You collect your information from two villages. One village has a population of 1,000, another village has a population of 200. You are going to collect probably 20 samples from 30 samples from here, 30 samples from here. So thousands or 60,000. From both villages, you collect 30 and 30. So in one village, 30 people, they are representing 1,000 populations. So you have to inflate the weight by 1,000 divided by 30. And then another, village is 3,000. So you have to inflate it clearly 100 times. That's your sampling weight. So whenever you are computing, so if you write down, so the weight for village A is 100 over 30 or whatever, 1,000 over 30, you write them. And then for this village, you write 1,000, 1,000, 1,000. Which whenever you are aggregating, you just have to make sure you weight them during the aggregation. That's how it works.
For example, we are using these names for random sampling.
Yeah.
There are, let's say, districts and blocks, then panchayats, and then households.
Have you ever read the manual of DHS about, or NFHS or IDHDS about their sampling design?
I think they do bits before the survey.
It doesn't matter before or after. But what I'm saying is that look at the manual, please, because they show how they compute the probabilities and all these things and how the weights are assigned. Same for you. You just have to make sure that they. So when we did for the city, for Kolkata, we had to ask for the Kolkata population map from the local municipality. They provided. For Mumbai, they did not. So for Mumbai, we had to get this slum population only at the ward level from a United Nations, but then we had to just know what the population, then we had to assume that they are probably proportional number of slum dwellers or whatever. You have to make some assumptions. But we could not do at the slum level because we did not have the data. So the weights are not going to be as perfect as for Kolkata or for Delhi. Delhi, we had to do at the district level. But we had some information how many slum dwellers were there in different districts and so on. So unless you know the population, you cannot create the sampling weight. So you have to know the population.
At least it would be primary.
Yeah. Yeah. Any other questions you have? Okay. Yeah.
So how do we decide this deprivation cutoff and poverty cutoff? So in the literature, what
You have to draw, for example, we had a discussion with education, right? We just cut off the literacy, cut off the 8 years, cut off the 10 years. So there has to be justifications from the literature. Now, as a researcher, you may have your agenda that you may be trying to push. So you may say that, look, whatever the literature say, I disagree. And I think this is how the cutoff should be. Right? Because whether the cutoff should be changed from 8 to 10, somebody has to speak up first. That look, it has to be done. So would be it's you. The first one say no, the deprivation cutoff. So it could be based on literature, could be based on international guidelines, could be based on what a country wants, could be based on literature. It's a mix of all. There is no unique way of doing. For example, for the slum, I showed you these different poverty cutoffs, right? We went to the literature and indicator by indicator, we looked at the literature, the evidence, and so on, and this is how we justify why we are choosing the cutoff. Yeah. Same for one of my PhD students who is working at this moment on Zambia, and she's trying to develop an index for the rural households. So she had to go and she had to defend how to. Now, in a regression analysis, people often make the mistake. The indicators that they use inside poverty measure, they also control for right-hand side. Now, that creates infinity. You cannot do that. So your choice of indicator even and the cutoff would also depend on that. You have to drop some of those variables on the right-hand side because you cannot have them on both sides. Yeah. So yes, my answer would be that there is no unique way of choosing weight. Now, weights, you have to provide your justification. For example, I asked, what do you think? Education should receive more weight or health? Unless you have, now if you do not have justification, there has to be equal weights. There is no other way. But you can always choose alternative weights, compute the measures, and then check for Kendall-Star rank correlation. See whether your ranks are changing. If it is not changing that much, that means your rankings are more or less robust. Question?
From starting, how we will follow steroids, like
we have data in different variables, like in an system data. It's very limited in different variables.
देखो पहले बात खा लो अच्छे से अच्छे से
Tomorrow they will cover especially the energy indicators. They will be covering. Pratap will be presenting how they do in tomorrow's we have a session. So what is it? You have a general question or your question is specific to energy property?
My question is how we will follow the steps. First of all, we open the data file where we have household sites. Then we will generate the weight. Then after that we will merge one by one the files where we have the indicators. Like that.
I'm asking how to generate. I'm trying to understand how to respond to your question. It all depends on the needs. I mean, if you need the data system together to generate the variables, you have to do the margin first, and then you have to do. I mean, I have never worked on NSS. For NFHS, for example, you have some information in the household file. Nutritional BMI information, they're available in the individual file, individual file. Then you have male file separately. Then you have children file. My suggestion would be to bring everything together and then create the variables one by one.
So
Yeah. I mean, I have not worked on all data, so I cannot tell you exactly. In NSS, I never worked, but Pratap has worked, and Pratap will show you tomorrow how they create the variables. Yeah. Questions?
The robustness which you are talking about, suppose for any kind of
PW
you are just getting the robustness for the dominance or you have shown cumulative distribution. So that's if you have been getting that FX is greater than FY or FY is greater than FX, then we have to do the
wait case and document
You have to do what? Repeat it again.
the test for the statistical significance.
If the dominance holds along with statistical significance, then you don't need it because you already show in your graph that the difference already holds. So
if there is an intersection, then we need to test it.
Yeah, the idea is that if confidence interval not intersects, it is statistically significant. Okay. It's different. Okay. If confidence intervals intersect, even then you can have statistically significant difference. So yeah, you have to just check. But it may be possible that you do not get significance. Yeah.
So just this one.
I would not do that, but it's totally your choice. If I see that paper, I mean, if it comes